Good morning. How are people doing, whoever's out there? Today I'm going to make the video that basically does the elevator pitch for Neutron Decay Cosmology, which is the cosmology I've developed over the last year or so, just looking at the facts that we know about curvature and gravity and how to put it all together so that it makes sense as a holistic thing, rather than just being what is going on here. Is there somehow that it all does nicely fit together? And I think I have found exactly that way. And unfortunately, I do not do the math at all yet. But I can draw you shapes and I will describe things, and if you are paying attention, it will make sense because it does. Okay. So first, let's just imagine a universe. Okay, now the way I'm going to draw this universe is, this is the energy density. Rather than being by distance, let's go by energy density. This would be a perfectly isotropic space. Gravity is the same everywhere. Lambda, or the energy field, Ricci curve. There's a little bit of energy. There's only lambda. It's spread. The material of the universe is spread everywhere. Actually, I guess it would be higher than lambda because all the places that are concentrated now wouldn't be concentrated then. But this would be whatever the curve is. It is what it is. This is the universe as an amorphous gas. This is not, as we all know, how the universe is, though. There's variation in gravity in energy densities. Okay, so what I am going to do is draw a curve. This is terrible. So we're going to draw a cardioid because it's essentially what happens. Ooh. It's hardly any difference, then all of a sudden it's drastic. Okay. This cardioid, this circle, would represent the an amorphous universe. Is this right? This should be 0, 0. Trust me on that, just do the math and you'll find out. Oh yeah, it's because this circle here that I rolled down. Actually, I will leave that up a little bit. And this is exactly rolling one circle, one revolution, from maximum distance to 0 distance. That's not an accident. This applies all over the place. Okay, so there we go. Okay, so both of these axes represent energy density. These are just different places. This would be deepest space, right? Like a void, one of those cosmic voids. And this, energy increase, which means gravity increasing, which means this point there, 0, 0, is event horizon. Okay, so in this universe, the one we live in, gas from over here slowly makes its way to nebulae, slowly makes its way, gathering someplace. I haven't done the math yet, but if we designate this as lambda, the minimalist density, most minimal density that we can have in the universe, and this as whatever we calculate to be that density at the verge of Schwarzschild collapse. And we'll approximate, because I know the math gets whack around there. May I suggest, instead of C, we substitute C in the future for Planck per second, which is a huge number. But when we start dealing with photons, I'm pretty sure if we play with the math, we can find out exactly how long, how many Plancks a photon is, because there has to be a length of a Planck that you could fold them to have various energies. But back to this. There we go. Voids, event horizon. Okay, so hydrogen goes. Here it is. We're at a neutron star. Okay, you're at the edge of a neutron star. Here's a neutron star. What I propose is essentially that the topology of the universe, this is space, what happens when this neutron star inverts and becomes an event horizon, black hole, as we call them. Once it hits that point, what happens is the neutrons, or their Hamiltonian, are transported via Marangoni effect. Because imagine if this was a tube, and they are transported to the very, very lowest density regions of space. There we have a neutron in space. It's the most compact thing. It's what everything is forced into. You start with a proton and electron. Once a proton and electron are stable, then they can acquire a neutron. So neutrons are like the nuggets, the seed that you make. But first you have to be a stable thing before you can make the seed. There's a neutron. It emerges here. If this inverts with any velocity at all, possibly c, then these neutrons are emerging with this velocity here. They decay in 14-ish minutes into primordial sort of atomic and amorphous, because whenever you see neutron decay, nobody indicates it as you get hydrogen. People always say, oh, you get a proton and an electron and, of course, an antineutrino, because charge came off of this thing in decay. The charge came off of it, so you need an antineutrino. When you need to put charge on, you need a neutrino. They are swirls. I consider these Aharonov-Bohm particles. All they do is they're the twist without any charge, and that's why they're so hard to detect. Charge is what manifests in the EM realm, but without charge there's still a current there somehow, and that's what we need to investigate. So, decay, transport, decay into this, which is atomic hydrogen. Okay, atomic hydrogen is 10 to the 14 times larger at minimal than as a neutron. This is where the expansion of the universe comes from. This is where the expansion of the universe comes from. This makes a perfect cycle as things get stretched, and I believe in an Einstein-Neutron Decay Cosmology, where look at, here's you, here's space, and what you're looking at. This is the farthest reaches of space. This would be, Big Bang if it had ever happened. You're looking, you're looking, you're looking. Then the light starts to get bent by the gravity of the universe, and it gets bent more and more and more and more and more and more and more. And someplace around here is where our cutoff is that we can't even see anymore. Eventually, down here is where you get that monopole component of the CMB, because everything just gets dragged down frequency-wise by the curve of space. Space is energy. It has an innate energy. That innate energy adds up in time. It pulls everything this way. There's no expansion to the universe as such, actually. It's just the collapse of gravity sucking. Here's a galaxy. Okay, in time that galaxy is going to be instead more dense and smaller. This is the without the cosmological constant, this is what Einstein feared. It was like, oh my god, the whole universe is going to collapse. We need to shove something in there to compensate for it. This is the physical mechanism of that. The transport of the neutrons, or their Hamiltonian, if you want to decide, via Marangoni effect. There. Now, this works functionally, but there's a slight flaw in this that I found when I was working with things. In that, instead of it being a simple surface of the universe, so this would be a surface of the universe, this would be the surface of the universe, and they transport up via Marangoni effect, and then it just opens up. So it would be a toroidal shape, a contorted toroid, because this represents gravity. Gravity is just density of energy in space. Density of energy in space. That is all gravity is. Okay, here's something with not very much gravity. When a photon passes through, it gets diverted as much, a certain amount, each time it crosses the line, let's say. Here's something with a lot of gravity. Density of energy in space. Oh, shite. Okay. The reason that gravity doesn't work with the other, with EM, is because its relation to EM is that it is the metric. Gravity is the metric alone. It is not a force on it. The metric curves. The metric curves. We live in a fixotropic space, and therefore when you put energy, it curves. The more energy you put, the more it curves. Boop. Ricci curvature is lopsided on one side. On the time forward side, we have a lopsidedness. This is the correction for the lopsidedness. But, as I said, you reach a problem here. This didn't make sense. But instead, what happens at either here or here is that this is not a singular membrane. I'm going to do a little tidying up for a second. This is not a singular membrane. It's a bilayer membrane. I'm going to get rid of all this stuff for now. Wow, I must seem like such a kook. Do the math. Neutrons are the easiest things. Everything balances out on a neutron. If you did neutron-antineutron pairs in each universe, it would be, the universe takes nothing to run. There's no friction. And if you design it right, it just literally falls into itself. Okay. Keep that. There we go. Okay, so let's call this present outward facing the universe, or I'm going to use lambda because I like it. We'll use lambda. And we'll use anti-lambda for the antiverse. So what happens is, this is one layer, this. It comes in, there's an inversion here. Let's make sure we can see the two layers. And this crosses there. And then this becomes because gravity is the manifold, this has to follow in both dimensions exactly the same way, if you get my drift. Okay. Hmm? There we go. Okay. This is the manifold design without that, the Ricci curvature, the gravitational thing, where this would be, let's say, this would be the more pointed end. Let's just say this is the navel. So this is influx here, convergence. This is gravity here. On the antimatter side, because space is also getting denser. Dense isn't, there's not a forward and backward on dense. There's less dense, but every place is less dense. It's not an inversion, I don't think, in that way, because the inversion happens in the charge spin realm. So there we go. So see, here too. And this is divergence. So this is where the neutron emerges and decays into a proton and electron, which is equal to hydrogen. That hydrogen then falls in time through space, becoming a nebula, becoming a star. We live in a steady state universe. It evolves locally all over the time. It's evolving everywhere all the time, forward in time toward a more dense situation, which is why the proton, positive charge, is also associated with forward time. Electrons, the sea of electrons, is the past floating around. Okay, there we go. So this goes down like this, this comes around like this. Okay, I know it's a little confusing. I wish I had colors. Better colors. Do I have colors? Not in dry erase. Okay. That's good. This is the infall. At this point, all the components are reversed. The neutron becomes an anti-neutron, but these two membranes are interlinked. Here is the center section, is the Marangoni current, which is like the photon flux, is the vacuum flux as an interstitial layer of energy. This is what you see at the event horizon. Well, you can't see it because it's 90 degrees from you, but this is all the energy just going back and forth at the speed of light. These are like little balls that roll. So I guess the current is I don't know. Maybe the both directions at the same time. But, and the thing is that because of this chirality, because of the membrane, okay, you have lambda here, you have anti-lambda here. Okay, so here, this is like clocks are seeing somebody from behind is the thing. Here's our universe, here's the other universe. In our universe, let's say we have there's a curvature, this is a divergence, so we'll call this negative charge in the EM. Well, look at, from the antimatter universe, what happened there? There was a convergence of exactly the same size. It's that simple. When you enter, if you put 3 spikes, this is going this way, but from their side, it's 3, it's axes of spin. To us, they're going clockwise. On the other side, they're going counterclockwise. Because we live on 2 opposite sides of a singular membrane composite, which I think is actually bilayer. these things continually balance each other out. As soon as you have any event, as soon as you have any event here, it is mimicked on the other side in perfect balance. The universe takes no energy to run. It gathers energy from falling into itself. That cardioid, circle, ball, ball. Okay, shoot, shoot. This is potential energy. Here's it turned into kinetic energy at the moment that this thing is falling at the speed of light into a black hole, or near the speed of light, into a black hole. This is the kinetic energy, this is the potential, this is the kinetic, this is all that ever happens. It's like it gets repackaged at a neutron star, emerges, the neutron emerges, but then it has this very active life until it collapses again. When I stray mathematical, I know this is a long video, when I stray mathematical I think, oh, you know, considering there's an infinite paths to life, then doesn't that match up with exactly the Riemann paradox? That there's infinite ways of getting from one to the ways that two circles can interact. There's infinity points here, infinity points here, and then their interaction is all the possible paths between all the possible surfaces and their relative distances and movements. It's like your life. You take 2 steps forward, you take 1/3 back, you take 1/4 forward, and a 1/5 forward, and an 1/8 forward, but then you take the 17th back, or whatever it is. Okay, that was really messy, and I need to do a better job, but this is Neutron Decay Cosmology. And I have a much better workup in Adobe with drawings of all this chirality stuff, but suffice to say, if you look into it, it's the only thing that makes sense. This is the Occam's razor of how to deal with what we know about the universe. Oh, time is also infinitesimal. That's how we get the membrane. Time is an infinitesimal compact dimension. This is why, as soon as something happens on this side, that antimatter thing happened again. It's almost like they're the two sides of a single ball spinning. Peace.